Hello everybody, and welcome to this month's BIM practice group meeting. I want to hand it off to our co-chairs of the practice group. So I'll hand it over to Beth Prochain as well as Roger Grant. Let them kind of update you on where we are with the practice group and what to expect in the coming months. And then we'll hand it over to Helen and Greg to start today's presentation.
Thanks, Matt. This is Roger to the BIM practice group meeting. We just wanted to give you a little overview of where we are and where we see the practice group going here. We've been working on a series of sessions about BIM and specifications, and we still expect to continue with that. We've got one more presentation we're trying to arrange on an approach to integrating BIM and specifications that Bentley software company actually is involved with. So watch for that session. And then we also plan to have a kind of a wrap-up on the BIM and specification series. But at the same time, we're getting a new series started, which is looking at BIM and other aspects of the construction process, working with construction administration and construction management. And we're starting that series off today, so I'm going to pass it over to Beth and let her tell you where that's going and then introduce our speakers for today.
Thanks, Roger. Hello, this is Beth, and like Roger said, we've been talking about specifications, and often we like to think that specifications are the center of the universe, but that's not always the case. A lot of the universe focuses on the construction side, and once we produce specifications and drawings and those kind of documents, how is the construction side using BIM and that same kind of information? Part of the promise of BIM is that we can pass information along, and if we know what the next person in line is doing with information, we can pass things along more effectively and use our tools more effectively. So today we have Greg Smith and Helen from Skanska here talking to us about what Skanska is doing with BIM. And so we've got Skanska today, and then we'll get a couple more large general contractors to talk to us about how they're using BIM. And we're focusing on people who are across the country, so our listeners from the West Coast to the East Coast have a pretty good chance of running into some of these great contractors. So with that, I'd like to hand it over to Helen and Greg and hear what Skanska's up to.
So thank you everyone for joining, and thanks Beth for inviting us. My name is Greg Smith. I'm the VDC director for the West Coast of Skanska, for Skanska USA building. And VDC to us is virtual design and construction. And presenting along with me is Helen Juan. She's our VDC manager in the Seattle office. And we're going to go through a variety of different ways we use BIM in construction. There's probably more slides on prefabrication than anything, but we're going to give you a real general overview of a variety of the ways we use it. So Helen, next slide. Skanska USA is in a variety of different markets, including healthcare, aviation, institutions like universities. We do a lot of small and large construction projects. In the USA, we have about 5,000 employees. Worldwide, Skanska has about 55,000 employees. One of the big challenges for Skanska related to BIM is making it ubiquitous across the entire country, rather than just having pockets of excellence in certain offices. Next slide, please. In this presentation, there's about 60 slides. Other than the agenda, there's about 60 slides, and we'll try and go through those as rapidly as possible and get to any questions. So this is the agenda. We're going to talk a little bit about planning and construction, and then the information as well. So one of the lowest hanging fruits for BIM, for us anyway, is the visual communication. And we do logistics planning on every one of our projects. The more we can communicate in 3D, it just helps the entire team see what's going on in the construction project, rather than trying to flip through 2D documents. So next slide. And this is another example of 3D logistics plans. So again, I mean, looking at that is a great visual communication of what's going to happen on the project. And we don't just share this with our internal team. You know, we can share this with the owner, and we can also share it like on a website or other way of sharing it so that the public can see what's happening as well. So next slide.
In this example, this is a unique example where we had an FAA ceiling. This is the Boeing Everett Delivery Center for the 787, and they were only given 4 points of elevation with the 4 corners of the site. So trying to communicate what was the maximum crane height operating limits was conveyed through this contour map, but then we also showed the ceiling in this elevation view. So they had an idea that it was a plane that was twisted in 2 directions. We also use the models a lot for virtual mock-ups. That in that same project, we were showing how we were going to execute this project from 2 different sides. It was a fast-track project, and showing where the FOD barriers were and the crane locations and how the sequencing would go with the steel and the concrete. And so,
go ahead.
Sure, go ahead.
I was just going to say, and you can click to show the next thing. Yeah, so one of the things we can do is on projects before we begin, we can take a picture of the site, and then we can ghost in what the finished product is going to look like. We've done this on a few different projects. One of them was there was a height limit to the height of the building, and we were able to show the city and show the neighbors what the project was going to look like, and we were able to get around that height restriction. Go ahead, Helen, next slide.
Here's an example of where you see on the left upper corner, there's a 2D plan. Oh, has it caught up yet? Okay. There's a 2D plan of the furniture, but it doesn't really give you a good idea of what the layout is from a user's perspective. So below is what you see is, you know, the 3D representation, and we also use this for a lot of our healthcare facilities. When we're mocking up the interior for patient rooms, there's like a lot of valuable space in the walls there, and the doctors and nurses have very particular needs for how all of their in-wall equipment is located. In this example, during construction, there was already a change out of equipment for a CT scanner, and it had different core drill locations, and the overall footprint was bigger. So in this example, we were fitting the equipment, and I mean, just 2 to 3 angles, you know, showing what the operator would see. So this was very useful for the Good Samaritan hospital project, because again, they had very, very stringent requirements for how the equipment was going to fit in the room and what the technician was going to see from the window.
And this example here is one where we were able to provide the images to the doctor, and the doctor actually was able to choose which orientation he wanted. So it was very rapid, getting the question answered from the doctor very rapidly, rather than trying to look at a 2D plan and try and guess what it's going to look like.
Again, here's another example of a healthcare facility with the patient beds layout and the scanner. You know, just showing we could add even colors, textures to it, so the staff completely have a good idea of what's going in, what they'll be receiving from the facility. All right, so construction coordinations. It's been the bread and butter of BIM for construction for over a decade now. And this is just an example of us running an MEP coordination session, and then a report is generated out, and those clashes are reviewed by all the trades and resolved as much as possible. Then we usually have a weekly meeting to address larger design issues, and for the remainder of the week, it's resolving those large design issues, and then the trades still, collaborate and move any, hundreds of numbers of clashes amongst themselves. Here's an example of a coordinated view with consolidated models, and then an in-progress construction view. So we try to take the model on field computers or iPads and use that as a quality assurance type of tool, actually walking the systems and making sure that what was coordinated is what's actually put into place. In this example, this was a model that we created in Preconstruction for the University of Washington Medical Center. There's a lot of existing utilities, and we're trying to, in this model, we communicated how the areas of influence from trenching for the new lines and pouring the new piles was going to affect the existing structure. Greg, do you have any more insight on this one? I know you worked extensively after I modeled this.
Yeah, it was just a good example of where the designers, they were kind of working in silos, and until we brought it all into a model and showed them how the foundation information was going to clash with the utilities, then it really sparked a lot of discussion, and we were able to resolve a lot of things early in the process. And I'll take this slide as well, Helen. This is actually off of one of the projects we did several years ago, and it was nobody at the time wanted to do MEP coordination. And if you look at this, if you're looking at the drawings, it looks fine in plan view, but if you look in the elevation view, you can see the equipment is sitting outside the roof. This got all the way to when we started trying to install the equipment, and everybody realized there was a problem. So it would have cost a very minimal amount of money to do the MEP coordination up front, although nobody wanted to do it. But in the end, it jeopardized the schedule, and it cost quite a bit for the change. Next slide.
So we also use BIM for safety planning, and in this example, we're just pointing out some of the temporary structures that were put into place for safety measures. So there's railings and fencings. Sometimes we will highlight leading edge where there's going to be hot work above. So the model could be used in a variety of ways, depending on who's your audience. So we tend to sometimes forget about those temporary structures, but they really have a huge importance during the progress of construction. And we've gotten into a habit now of creating a schedule of the plans and lift drawings that we intend to create from the models, so that we can stay ahead of the work, so that we could stay ahead of any safety concerns. Here's, the models could really be used for ensuring the safety throughout the life cycle of a project. As you see from this picture, there's many valves in the structure that aren't accessible except through a scissor lift, whereas you could have easily designed a catwalk to access all this equipment. You look over the course of the lifetime of a project, and what's the cost of the hazards that you're imposing on your personnel, the time lost in just obtaining the scissor lift, putting it in the right place. I mean, there's productivity efficiencies there, versus a one-time install of some permanent infrastructure that can safely allow the maintainers to access all the systems.
So a big part of lifecycle safety is it's not just making it safe to construct, but it's making it safe to operate as well.
And then we have some techniques by having superintendents work with the model. And they're able to think of ways where there's safer means and methods of construction. So on the Good Samaritan project, we're looking at the embeds in some beams. The ceilings are the floor to floor height is 15 or 20 feet. There's a lot of interstitial space. So working with the superintendents, they're able to tell us, what methods could we install the embeds at the floor level before we cast the beams, and then raise it all up. So in this example, we really saved from the steel workers some time and also improved safety by having that beam welded to the embed prior to it being lifted into place and the concrete poured. And then we have some construction simulations. For 4D sequencing, this is just the skin of a healthcare project where we're showing the sequencing of when the glazing would be going up. Now, this wasn't actually animated, but it was just something that could be simply colored so that we could convey where the glazing subcontractor was going to be at the time, and then the trades that were around those areas could plan accordingly. Greg, I'll have you take this.
Yeah, and we've got a 4D simulation, but trying to broadcast that over WebEx, it doesn't usually work. So this is just an image of the Meadowlands Stadium in New Jersey, how we created a 4D simulation, and it showed the steel being erected. So I'm sure a lot of people have probably seen a 4D simulation, but it's just tying the schedule to the elements within the model and then creating a little movie. So go ahead, next slide.
So this is what I alluded to before. This is one of the examples where we use it for really nailing down the locations of everything on the walls for patient care rooms on one of our healthcare projects. And there was a lot of unknowns, so anything that was red were things that were really not defined, and things that were in blue were kind of hard set in the issued for construction drawings. But this gave from the ceiling, floor, each of the walls, and then isometric views for each of the patient rooms. This is we also used it for a lot of the site improvements, and there's this particular area. There's a parking area that they realized that they needed some additional parking for handicap, and there were a lot of steep and funny slopes in the site. So we used the model to show proper drainage and provided northing easting for the surveyors. It was just a great example of like a small complex area that we were able to knock out because, just because of the use of the model. And then from this we were also able to extract volumes for concrete because there was like a lot of different slopes there. It was kind of tricky to calculate the volume, so through the model we were able to easily just produce a schedule. Another example of such a case, sidewalk leading on the south is leading to a parking structure. On the north side it was a big entrance for the hospital. So we assisted the civil engineer because they were having troubles with a lot of pooling and having it drain properly from the entranceways and not drain into the parking structure, for example. So we worked with them and were able to redesign this walk. And that's the kind of partnership that we really see through the use of using BIM, using modeling software, is that we're able to work with the designers and looking at these design issues and help resolve them. And this is just an output from the software, so that we can just take a robotic layout and they can easily shoot it in.
So this project, it's a project in Portland, and we've got a superintendent on the site detailing everything in a Revit model. And you can see the image to the lower right. That's kind of the shape of the building, and there's this roof with all these different funky slopes, and it's challenging to figure out, especially in a 2D environment. But once we can visualize it in 3D, we can see what's going on. And then you can see the picture in the upper right. That's a mock-up of one of those roofs. So we built the mock-up to see how everything is going to fit together based on what we were modeling. Next slide, please. Okay, and so when we got the drawings from the engineer, it did not show the rebar bent at all. It was bent at a 90-degree angle, but based on the slope of the roof, we had to bend the rebar in a certain fashion. It's really hard to see in the picture, but some of those bars are painted, and that was helping the field guys orient those columns in the proper orientation. So when we pour the roof deck, the rebar is not going to be sticking out of the roof. Next slide, please. And Zeke, the superintendent, he's very self-sufficient on this project. He is building the model, and he's adding points to the model, and then he's extracting those points and using it in a robotic total station to go lay out the site. Next slide. This is a little bit different view. This is actually an excavator, and they are excavating the bottom of a bay. And if you go to the next slide, Helen, this is, this picture shows the inside of the cab of the excavator, and the guy is basically playing a video game all day long. If you can go back one.
You moved ahead. I didn't even touch it. Sorry.
He's basically playing a video game all day long, just watching on his screen how the digger is excavating. So our kids that are playing video games these days are going to end up being great construction workers. So next slide. And we also use the models to extract quantities for quantity takeoff and for estimating. So in this example, we took the structural model and we extracted the quantities, and we also did a traditional takeoff. A traditional steel takeoff takes about 40 hours for this size of project, and the model takeoff took only a couple hours to extract the quantities and then compile the data and compare it to our traditional takeoff. And if you see that at the end of the day, there was less than 1% difference between our traditional method and the model takeoff. Next slide. We can also use it not only for quantity takeoff, but to figure out how to construct projects. In this example, there were 118 different, unique columns, all with very different heights. And it's hard to see in this model image, but the roof is sloping in multiple directions as well as the floor slab. This is for a reservoir in Seattle. And our estimators, we're just going to take one column and just say, okay, just average the number or the height of the column across all the different columns. But we were able to build a model very quickly and develop an estimate, a more accurate estimate. So next slide. Prefabrication. So next slide. Okay, we've done prefabrication on a number of jobs. We're probably one of the leaders as far as construction companies developing prefabrication strategies. Healthcare is a great area for doing prefabrication. The example here is the Smith County Hospital in Virginia. If you can go to the next slide. So what we start out with is we take a floor plan, and this is for mechanical racks, mechanical and electrical racks. We lay out the racks in the corridors to plan where those racks are going to be. And if you go to the next slide. And click it again, Helen. I think there's an animation there. So this just shows how those mechanical racks are going to be laid out. And this is after our MEP coordination is done. We lay out those racks. And then if you go to the next slide, one of the things people think about with prefabrication is identical parts. And what we do is focus on not just identical parts, but parts that we can identify and detail out to build in a warehouse environment. So we can focus on one of these racks. And then if you go to the next slide, we can detail out just that rack, and the models are parametric, so if we change the size of the duct, it's going to change it in our shop drawings as well. If we move something around, it's going to change it in our shop drawings. So then we can go, if you go to the next slide. And this shows the rack after it's been built. One of the things with prefabrication, it really speeds up the schedule, and it also makes it a much safer site. You don't have nearly as many people on site. And like on this example here, and you can go to the next slide as well, Helen, we can attach the partition to the rack before we install it. Go ahead and click again. There's an animation. So that's, again, showing a detailed model and then how it's being constructed. And if you click it again, I think it shows it installed. So we wheel the rack into the site, and then we just hoist it up and install it on these tracks on the ceiling. And it's a pretty much fully contained unit. And that's showing an entire row of those racks being installed. Go ahead to the next slide. This is another project as Kendall Regional Medical Center in Florida, and we prefabricate bathroom pods instead of the mechanical racks. So go ahead and click on the next slide. So again, we lay out those bathroom pods, and in this example, the pods are fairly similar. So where the mechanical racks are all different, these are mostly similar. So go ahead and next slide. So we can show, down to the studs and all the mechanical and electrical equipment. We detail it out in 3D. If you go to the next slide. And showing those 3D bathroom pods again on the floor plan and in a model. If you go to the next slide. And here's where we develop the models into shop drawings and bill materials. And if you click on it again, it'll show, there's animation that shows the bill of materials. So we can break the models down into separate parts and shop drawings to send to the warehouse to build. I think there's one more animation there. so it develops a bill of materials for you as well. Then if you click on the next slide.
It's a considerable delay here.
Yeah, and this shows the bathroom pods being constructed in a warehouse. You know, a big part of prefabrication is building them in a manufacturing environment, putting them on a truck and taking them out to the job site to be installed. Again, cleaner job site, safer, and it can really speed up the schedule. Next slide. And once we get them to the job site, we can fly them in with a crane into the appropriate floor and install them from there. So next slide.
So a big part of constructing something correctly is ensuring everyone has the correct information. So a lot of the traditional method is that you get red lines, you mark up those on hard copies, and then you know, everyone copies those red lines. You hope that all the subcontractors have caught that as well. But something that we've implemented for, it's been about 5 years now, is the electronic version of that. So we redline PDFs and create hyperlinks so that anyone in the field will then be able to access those changes through what we call our digital resource stations. And this is the first generation of it, where it's just a large screen and one of those flexible keyboards that was used so it wouldn't be affected by the dust. And we had this on every other floor for our project, so that, again, if you needed to get to information, you could just print it off right there in the field instead of having to go trek back over to the construction trailer and review the record set. The next generation, we use a job box. The problem with this was that it was really only good for when you're doing kind of rough work, because the job box doesn't typically fit into like a 3-foot door. And then after that, created yet another version until finally now we have a nicely fabricated digital resource station that it's good for both indoor and outdoor use, and you know, it's highly portable.
And it fits through a door.
Yes, it's an important part. So here's a close-up of our PDF redline drawings. All of those boxes are hyperlinked to RFIs, DCNs, ASIs. So let the animation catch up here. And it's simple as that. You don't have to reference the drawings and then go to a binder from the traditional methods.
One of the newest things we're doing is taking the information out to the field. We have the digital resource stations in the field, like Helen said, on multiple floors in different projects. But you know, the newer technology like iPads, we're using iPads more and more every day, and it's a lot of the same information that is on the digital resource stations. It's the exact same information. It's just that now our superintendents can just walk out in the field. Instead of having a roll of drawings, they have all the most current information at their fingertips. The next slide. We also barcode equipment and different aspects of the project. We've used tablet PCs and other software to catalog some of that equipment and use it for quality control and things like that. Next slide. And we we've used it for supply chain management as well. So you can click on one of those barcodes and you see when it's been installed. You can see a piece of equipment if it's been received on site, or the status of that equipment. Next slide. This is the Meadowlands Stadium in New Jersey. We were using RFID tags, radio frequency identification tags, and scanning the precast concrete seats. They would be scanned at the manufacturer. When they were constructed, they would be scanned again when they were on the truck ready to be shipped. They'd scan them on site, and then when they arrived on site, and then they'd scan them when they were installed as well. So then we could, again, using a database software, we were able to see the status of that piece of precast. Next slide. And this just shows what the RFID tag looks like, the reader, and then the software, and how we were able to use the software. Next slide.
Yeah, what was also important about this project is that, you would think that a lot of the precast would be standard, but it wasn't. There were a lot of unique angles for each of these pieces, so it was very important to keep track of each piece, because you couldn't put in the next piece. So it was very much a puzzle instead of just a standard cut for all of them.
I was trying to look at there's a question, and I was trying to read that. I'll read that in just a second. So we also use this on, this is the Hunt Library project back east. We use the same material tracking methodology on curtain wall panels. And again, they were, most of them were unique panels, so we were able to track when they were manufactured, when they were shipped, and when they were arrived on site, and then the status of when they were installed. So you see the different colors there, and the different colors represent the status of that piece of curtain wall. So the question, let's see, no chat box on iPad app. How do you get your subs on board with using BIM? For example, the CT M362 MRI example you showed does not look like the actual model that would be provided by the MRI shield vendor. It looked more like a generic layout provided by the architect. Well, fortunately for us in the Northwest, actually on the West Coast mainly, our subs are very BIM savvy. But we do have documents that we use for bidding and for contracting, MEP BIM coordination and specification guidelines. So we write it into the contract with the subs to get them on board.
In that case with the CT scanner, we had to take, because we didn't have the model, the owner didn't want to pay for the model from the manufacturer. We just took the shop drawings and we generated close to the geometries, as much as we could, the geometries ourselves. So there's a lot of manufacturers, especially for high-end equipment like that, that have their own models, but at the time they were charging like $500 for that model. So I think from making our own CT scanner and then using that in the model, we were still able to communicate the idea to the owner.
And one of the things with BIM, it's a very iterative process. So when we're early in conceptual design, the models that we're getting from the designers probably don't have a lot of information in them, and then we can add information along the way. And so by the time we're in construction and our subs are on board, they're detailing out their scope in BIM and providing those models to us. As an example, when we get a structural steel model from a designer, it's going to have columns and beams, but then working with the steel fabricator, it's going to have gusset plates, connections, all of that in their model. and we can replace that model, or use that model rather than the structural design model for construction and for MEP coordination, things like that. I hope that's answered the question. Next slide. So, Helen, are you going to talk about this, or?
Oh,
No, I guess I am.
I lost the screen that shows what you guys are seeing.
Okay, so
I'm kind of operating blind here right now.
Okay, we've also used BIM for facilities management, or basically a facilities management handover to the client. And what we do is we take things like O&M manuals, equipment schedules, warranty information, the training videos, photos, project photos, and we associate those with the models. And on this project, we use a product called Artra, and you can see the pane when you click on an object. So the blue object in the model there, it has all those links attached to it, and then you can click on one of those links, and it'll open up whatever you're trying to find, whether it's the O&M manual or the training video, things like that.
Now, if when we export from a model, any information that's embedded in that model, all the attributes for those components are brought into this platform as well. So this is a platform that uses Navisworks, and so it wasn't so much just what we manually connected from the O&Ms to the model, but also it was very valuable what was information that was already embedded into the model through the software. So if you have specifications attached to that, if you have hyperlinks within we're using Revit, then that information was not lost. It was also transferred into this O&M facility management model.
Oh, wait. Okay, so we build data centers as well, and one of the things with data centers is we save them a little bit of money on energy, and it saves millions of dollars. So we use the BIM model, or the 3D models, and we link that to the equipment, and we monitor the status of that equipment over time. And in this example, you can see there's like server racks, and we can see how those server racks are operating. Red is bad, green is good. So we monitor that. We also monitor the mechanical equipment within the facility as well, again, to monitor the energy being used, so then we can come up with strategies to save energy, which saves, again, millions of dollars. Next slide.
Did it? Oh yeah. Okay. So when we're working with the owners, and they want to have a BIM-enhanced facility management tool, we ask, what are the things that they're looking for the tool to do? There's a big variety. Are they looking to increase their energy efficiency, like in the data centers? Do they want it to integrate with their work order system and to streamline their preventative maintenance plans? There's also just managing their spaces, leasing. They want the BIM to be a sort of portal for all the users to visualize the space and be able to even send emails through. So if they wanted to move from one room to another, then they could have an estimation of the wall space, what kind of cost is associated with that move to make that space work for them. And of course, retrofits, renovations, and new construction, the models that we deliver are as-built, so they're intended to be used in the future for future planning of work. And then also, finally, just the overall life cycle management of that building, so that asset management, they can plan well ahead of time for when things need replacement, and they can also plan for when new equipment's coming in, what that will take cost-wise, if they can even bring it into the building, if they have to open up a wall in order to bring a large generator in, you know, or something like that. So BIM for facility management it's kind of a realm that's really growing right now, but different users and even different users within that owners group will have varying needs for what they want the software to do. So it's really important for us to sit down with the owner as early as possible and figure out who are all the users, what are their needs, and, you know, what's the most achievable, because there's always a limited amount of resources.
So this is the last slide before any questions or comments, and we just wanted to leave you with you know, some of the things that have been important to us and lessons learned. And the number one thing there is early engagement and collaborative mindset. You know, the traditional way of working is working in silos. And let me give you an example of that. If I send out an email to one person, that person responds, nobody else is involved in the discussion in that email. But if we were using Facebook, I post something to Facebook and everybody on the project team sees that discussion going on, and they're able to respond to that or just learn about that aspect of the project. So breaking down some of those silos and making everybody more aware of what's happening on the project is huge. So Helen, you want to take the next one?
Yeah, for MEP coordination and involvement, we've really, I think, even though it's been in use for a long time, we continue to evolve and train smaller subs. So we're seeing a lot more subs come on board, see the value of 3D coordination, but also they're beginning to see the value in making these information-rich models as well. So it's not just geometry, it's they're intelligent pieces of components. So when we turn it over on the final as-built, the owner has some useful information regarding that equipment. And also with the acquisition of the, you know, one of the big MEP software developers, MEP, it was acquired by, you know, Autodesk. We're hopeful for even further integration with that. That kind of goes into, that kind of goes into the, you know, subcontractor management and specialists and support. It's as a general contractor, you know, we do see ourselves as being responsible for educating how to use the models well together. One of the main issues that we had early during the BIM process, and we were trying to do MEP coordination, was people weren't using shared coordinates, you know, and we're still seeing that every now and then, especially with some of the smaller subs coming on board, is that they'll create a model and you know, it doesn't have the same reference points, or they're building according to a grid, but you bring it into the drawing and it's like 2,000 miles away from where your drawing is originated. So we take it upon ourselves to really work with the subcontractors, train them, establish standards as much as we can through the contract, and then, you know, go back to the contract and continue to retrain, because a lot of times people aren't reading, you know, all the addenda, all the subsections of a contract, and then they miss certain things like that we're looking for attributes with components. So it's really important for us to continue training the subs that we work with, and then hopefully, you know, contribute to the overall forward movement of using BIM.
And one of the things that Skanska is doing more so now than several years ago is taking the lead on the MEP coordination. what was happening is, I mean, traditionally what would happen is you'd hire like the mechanical subcontractor or one of the subcontractors to lead the coordination effort. But what would happen is that particular contractor or subcontractor would focus on only their scope of work and not really care about everybody else's scope of work. But you know, at Skanska, we're concerned with everybody's scope of work. So the more we can take the management role there and lead the effort, doesn't necessarily mean we're pushing all the buttons, but it means we're leading the effort. It makes the process a lot smoother. The next bullet point, I have that GIGO model, and that's garbage in, garbage out. Frequently have somebody come and say, can you model this and you know, do it in the next 2 hours? And there is no easy button. We can do it, and we can do it in 2 hours, but you're going to get what you pay for in 2 hours. So business development versus field use is we can build a model very quickly, a pretty model that somebody can use to go out and present to a client. But when we get into construction, it usually takes a lot longer to build a model that is dimensionally accurate enough for construction. Helen, do you want the next one?
Right, and so like the Revit families from suppliers, for example, that's a great segue to that. For a lot of our healthcare facilities, we were getting some models from architects, and they were showing where the sharps holder is and where the patient bed and, you know, the head wall and foot wall was going to go, but they weren't accurate. So when we actually were receiving the submittals, we had to go in and we had to fix these families in the model. And then we soon found that there wasn't enough wall space, or there wasn't enough clearance per OSHA standard, or for some of this equipment. And so it was just a good example of how we really have to check the model and make sure that these geometries are accurate. You wouldn't think a hand sanitizer on a wall would be a big deal, but it can't be within 6 inches from an outlet, for example. You know, moving something like that after it's already been installed and you have something like 100 patient rooms, could really wreak havoc on your schedule, on the cost, you know, and impact a lot of different trades. So, but now we're seeing a lot more suppliers producing their own Revit families, and you know, if you just go on Autodesk Seek, for example, there's a lot of families there directly from the manufacturer. So we're really appreciative of that, because it's less modeling that we have to do on our side, and it's, you know, it's never as good as the one from the manufacturer.
So technology is our friend, but the one thing I want to say about technology is keep it simple. You know, that you don't need to overcomplicate things. And then from electronic O&Ms to BIM for FM, begin with the end in mind. Sit down at the beginning of the project and determine what you're going to need at the end of the project, and sit down with the owner to determine that. So the question is, let's see, has Skanska documented standards for BIM execution with designers? In other words, how can designers contribute to this process? We have, and actually probably the biggest thing we can do is sit down as a team at the beginning of the project with a BIM execution plan, and sit down with like a model responsibility matrix and determine what the designer is going to do and what we need the model to look like for us. One of the things I caution everyone about is designers create design models, and we create construction models. So to set expectations, it's not that we're going to get a construction-ready model from a designer. So the designer takes it to a certain point, hands it off, and we take it from there. Like a structural model, for example. Structural engineer will take the model to a certain point, we take it from there, we add the detail to make it constructible. Any other questions or comments?
And I have a quick question, Greg. I've worked with many general contractors, including Skanska, and one of the questions that I always ask from the spec writer's seat is, what's the best form that specs can be in to be used by this process? Is it attributes of components? I've never done that, but could. Is it PDFs? Is it something that can link into a software?
Yeah, so as long as it's in electronic form and like there's a spec number that we can associate with an element, we can link it to the model. There are tools out there if we're using Revit as an example, and I'm not out here promoting any certain product, but if we're using Revit, there are tools out there like BIM-link from ID8. BIM-link can take an Excel file and link items in the Excel file to elements within the model. So you can extract all your different objects out of the model, you can update those in Excel, and then you can put that right back into the model. So that's one method. I think there's some other software out there that can link specs to elements in the model, but we haven't played with that a whole lot. But being in electronic form really helps.
Okay, that sounds great. And we also got one more comment that says, to Skanska, thank you so much for sharing exactly the kind of contractor I'd like to be teaming with. So I just want to say thank you so much for sharing, and this has been very informative.
Okay, great. Thank you.
Great.
Thanks for asking.
All right.
Thanks.
Yeah, thanks very much, Craig and Helen.
And to everybody on the audience, I hope you enjoyed this, and we will be hearing from some more general contractors in the coming months to see where BIM is taking the construction process and how we can contribute to that process. So thank you, and have a lovely afternoon.